Hello everyone, welcome to day number 26 of the series. And I don't know about you guys, but the weather here is like really hot, bro. Like, it's so freaking hot. Bro, I need to have like two fans at the same time. It's crazy. And so anyways, I'm gonna do this question. It's the pendulum question. It's about energy, work, and power. So yes, we're doing this. Yeah, let's get straight into it. Number 4. A pendulum consists of a brass sphere of mass 5 kilograms hanging from a long string. So, okay, the sphere is pulled on the side so that it is 0.15 meters above its lowest point. So right here, right? Okay, and then okay, it is then released. How fast will it be moving when it passes through the lowest point? So it's asking about the velocity right here, right? Okay, so let's say, oh shit, wait a second. I pressed the wrong button. Okay, I'm sorry. So yeah, right here. Okay, so yeah, let's do this. So we're gonna be using some gravitational potential energy and kinetic energy transfer for this equation, for this question, right? So to find the gravitational potential difference between them, right? It starts at rest. It starts at rest, so it has some kind of a height right here. So it has some kind of a gravitational potential energy, and then this still has some gravitational potential energy, right? But we don't really care about that. We only care about the energy transfer, the gravitational potential energy that are transferred to kinetic energy. Those are the only things that we care about. So how to find the GPE difference. So we already have this, right? So we already have this. So yeah, do that. So the GPE difference, ENCE difference, is gonna be MGH. Mass, what's the mass? A mass of 5 kilogram, right? Mass of 5 kilogram. Should be, I'll use 9.81, and the height I have to use 0.15. I'll say that is delta H. So yes, 0.15 meter. I'm sorry if my chair is like really loud and making like squeaky noises. I can't really do anything about it. Like, this is the most comfortable chair I have. So yes, let me take my calculator, and we just need to solve this in a calculator. This will tell me the GPE difference of an object, right? So 5, 0.81, 0.15 meter. We get about like 7.36 joules of energy, and then this GPE is gonna be the same as kinetic energy because energy is conserved and it changes form to gravitational potential energy to kinetic energy, right? So kinetic energy is gonna be 7.36. Okay, so now what we need to do is just find the velocity. So the kinetic energy formula is gonna be kinetic energy equals to 1/2 AV squared. Well, mv squared. What am I doing? mv squared. 1/2. M is 5, I think. Right? We have 5 kilograms. Velocity is meter per second, which we don't know. Kinetic energy is 7.36. Okay. So v squared equals to 7.36 over 1/2. 1/5. It's about 2.9 or about 3, right? So let's just say 3, right? So velocity will get √3 meter per second. And then yeah, this will be the meter per second. This second of the ball. Okay, so we can keep this as a root, or we can just go and use the calculator. About like 1.73 meters per second. So the ball will be moving at 1.3. 1.73, my bad, 1.73 meters per second at its lowest point. So yeah guys, this is gonna be the end of today's video, and then I'll see you guys tomorrow. Goodbye, have a great day.